So rational inequalities are solved very similarly to what we did yesterday, okay? I'm going to do an easy example. I'll move on to some harder ones, okay? So what I would like to do is I would just like to start with number 1, okay? So what I would suggest doing is put everything in parentheses. Remember yesterday in the notes, the first thing we did was relate it to 0. That's done, check. The next thing we did is get it into factored form. These can't be factored any further, check. So those 2 things have to be done for these as well, okay? So that isn't going to change. Here is what's going to change. Not much. We still find the zeros from the top. We find the zeros from the bottom. We make those into a number line in number line order. The factors from the bottom always get an open circle where they have a 0 because fractions can't have denominators that are 0. Bottoms always get open circles no matter what. But the tops are determined by the symbol in the problem. The symbol in this problem is a less than, so remember, we don't include it, and we just want the negatives. So this is also an open circle. Okay, so let me say that again. The bottom factor zeros are always open circles. The top zeros are going to be based upon the symbol in the problem, okay? So now we're going to do exactly what we did in the notes. We're going to make this into a plus or minus chart. We're going to put any factors, whether they are from the top or bottom. Here's why. If you multiply 2 positives, it's a positive. If you divide 2 positives, it's a positive. So multiplication and division signs work exactly the same, okay? We need test values. Let's test 0, 2, and 8. It can be anything within that region. And all we have to put in our chart is if we get a plus or minus because of that. Well, let's plug in 0 to both of those. If I plug 0 into the top, I get -7, so that's a negative. If I plug 0 into x minus 1, that's a negative. 2 negatives divide and give me a positive. Let's plug in 2. I get a negative, I get a positive. 1 negative gives me a negative. And if I plug in 8, I get a positive and a positive. 2 positives make a positive. Now go back to your symbol. Our symbol was less than 0. That indicates negative. So let's go ahead and color in the negative portion. It's only this. And let's put that in interval notation. My x's have to be between 1 and 7. They get parentheses on there because of the fact that we do not include them. Unlike the last one, where either all the ends will always match as far as bracket or parenthesis, the zeros here, one might have a bracket and one might have a parenthesis, and that's okay. That's just, you know, going to happen. But otherwise, the process is very, very similar to what we had done in the notes, okay? Now, I would like to look at 3. Anybody notice what's wrong with 3? Yes. It's not related to 0, right? That's an issue. So this part is the grossest part of these problems. Okay, so what we're going to do is we're going to subtract 3 from both sides. I am going to put the 3 as its own unique thing as a subtraction, and I'm going to put it over 1. Here's why. Okay, surround all 2-piece things by parentheses. We need to get a common denominator. We're going to multiply the top by x plus 6 and the bottom by x plus 6 so we can get a common denominator. You must combine all fractions. You must combine all fractions for this to work, okay? So now we know our denominator is x plus 6. But let's combine the tops, okay? So it's going to be x plus 32 minus 3x minus 18. That -3 is going to distribute to all the pieces of the x plus 6. And then we get negative 2x. We get negative 2x plus 14 over x plus 6. Now, let's talk for a moment of what we did in the notes yesterday. In the notes yesterday, I say, first thing, it has to be related to 0. Second thing, it has to be in factored form. This top can be factored by removing a 2, and I get x minus 7. Now that it is in factored form and it's related to 0, all of the hard parts are done. The hard parts are done. Okay? Now, as far as the zeros that we're going to put on our plus minus chart, negative 2 is going to have to be a factor that shows up in our chart, but it's not a 0. Negative 2 is not allowed to equal 0, but we do have to include that factor in our chart. X minus 7 equals 0 at 7. X plus 6 equals 0 at negative 6. So the only zeros that we're going to include on our chart are negative 6 and 7. Negative 6 came from our bottom, so put an open symbol. 7 is determined by the symbol in the problem. It says less than or equal to, so it gets a closed end dot. So I do that first, so then my bracket and my parenthesis will just kind of flow as I go, and then I don't have to worry about that as much. Okay. Now, when we make our plus minus chart, there were 3 factors in the problem. There was negative 2, there was x minus 7, there was x plus 6. You must include all factors in a problem. Now, why? Well, if you multiply through by a negative, it flips the symbol, it changes things. So you always have to include, especially when it's a number like negative 2. It is going to influence our answer. So we know no matter what, negative 2 is a negative number. So you can just kind of, it's always negative. So I'm just going to put negative and negative, negative. Okay. Test values. Let's do negative 7, 0, and 8. I don't know. Those will work. Okay. If I plug negative 7 into both of these factors, I get a negative 14, I get a negative 1. 3 negatives make a negative. Let's plug in 0 to all of those factors. I get a negative 7 and a positive 6. Let's plug in 8 to all of those factors. I get a positive 1, I get a positive 14. Now in the center there, we have 2 negatives, which will make a positive. In the farthest end there, we have 1 negative, which is going to make a negative. Now go back to your symbol. Less than or equal to 0 means I include the zeros if they're from the top, and I want less thans, so I need negatives and zeros from the top. Now I put my zeros from the top. That's 7. I already made a closed-in dot to remind me of that. But let's go ahead and color in every place that we have a negative. So what is our answer? Well, I can use anything from negative infinity up to negative 6, but I don't include the negative 6 because it came from the bottom. But I do include the 7, and I can keep going to infinity. So there were 2 regions. That's why my interval notation includes 2 regions. So for every one of these problems, I need to see the factored form related to 0, the calculation for the zeros, and the plus minus chart, and then of course your final answer. Okay, let's keep going. Now 5 is actually, it looks complicated, but they related it to 0. They have factored it, so that one shouldn't be too bad. It should be kind of ready to go. I would like to do one that is not ready to go, number 7. Ugh, it's a gross one. So I really want to do this one together. Okay. Put your multiple pieces, please, in parentheses. We have to first relate it to 0. So we're going to add the 11 over x minus 6 to the other side. Give yourself a little bit of room between the fractions so that we can fix the problem that the fact they do not have common denominators, we must always combine the fractions before we make our plus and minus chart. Okay. So to get a common denominator for funky fractions like this, just multiply this one by the opposite denominator. So I'm going to multiply by x minus 6 on top and bottom. And multiply this one by the opposite denominator. I'm going to multiply by x minus 5 on top and bottom. Now, the bottom, just leave it in factored form because we want to see those factors. So just leave that in factored form. Because to add fractions, if they have a common denominator, we just keep the bottom. The only thing that's messed up is the top needs to be multiplied out so then I can see, can I make it prettier? Okay. So I'm going to multiply this one by negative 10. I'm going to multiply this one by 11. I'm going to see what the heck happens. If I multiply that first one by negative 10, I get negative 10x plus 60. If I multiply positive 11, I kind of connect these two so then I can just distribute in one fell swoop. 11 times x is 11x. Positive 11 times negative 5 is negative 55. And then let's combine as much as we can on top. Let's see what happens. 11x minus 10x is x. That's a good sign because that means it's not going to have to factor further. 60 minus 55 is plus 5. So we not only have it now, one fraction in factored form related to 0, we are ready now to make our plus and minus chart. So that's the hardest type, what we just saw right there. So if you were able to follow that, that's the hardest kind, okay? Now, let's make our plus minus chart. What are our zeros? The top 0 is negative 5. We color it in because it's related to the symbol. The bottom zeros are positive 5 and positive 6. Those have to be open circles. Everything that comes from our denominator is an open circle. So now let's go ahead and put those in number line order, negative 5, 5, and 6. Remember, our top factor was the x plus 5. That negative 5 has an equal to symbol, so we're going to color our negative 5 in. But the two factors that came from the bottom, positive 5 and positive 6, they came from the bottom, so zeros can never happen in our denominator. Always make them an open circle. So top ones are determined by the symbol in the problem. Bottom ones are always open. Okay. Now let's make our plus minus chart. There are 3 factors in my fraction, so I need 3 rows. So my factors are x plus 5, x minus 5, and x minus 6. What are some good test values? I don't know, negative 6, 0, 5.5, and 7 work. You can definitely choose. There are millions of options. I'm just showing you what occurred to me. Okay, a person sitting next to you might choose something different. You might choose something different, still get the same answer. It just has to be within that region. Okay, so let's go ahead and test those values. Now the first value I'm going to plug in is negative 6 to all of those, and I'm just asking myself, is my answer when I plug that in positive or negative? If I plug negative 6 into the top, I get a negative. This is a negative, this is a negative. 3 negatives stays negative, so that region is below the x-axis. That region is negative. Now let's plug in 0. I get a positive, a negative, and a negative. 2 negatives, multiply or divide, doesn't matter, and gives me a positive value. Now let's plug in 5.5. I get a positive, and a negative. There's only one negative there, and so that one is a negative region. So that's below the x-axis. And then if we plug in 7, we get all positives down the board. So that region is above the x-axis. Now, what is our final answer? So we're going to go back to our simplified version. It is a greater than symbol. Greater than symbol means that we want the positives on our plus or minus chart. So go back to your plus minus chart and fill in the positive region. And then pull that out and interpret that as an interval. That is the answer. So I want the x's that are between -5 and 5. Now, -5 is included because it came from the top, so it gets a bracket. But +5 and 6 will not. So it will go from 6 to infinity with a parenthesis on that 6. Remember, infinities always get a parenthesis because we can't really land at a spot. We can keep going and keep going and keep going. Everybody good with number 7? Kind of disgusting, I know. It is what it is. Now, I would like to do 9 with you. Actually, let's go to 6 first. Let's go to 6 first. Let's do 6. Now, remember our steps. First step, relate it to 0. Second step, combine fractions. Third step, factor. Then you find the zeros, and then you make the plus-minus chart. So that's kind of the steps we're going to take for every one of these problems. Relate it to 0, combine any fractions, get it in factored form. What are the zeros? Plus-minus chart. So keep that in mind as you go through these problems. Those are the steps that we want to take. Okay. Okay, so it's already related to 0. It's in one fraction, so all fractions are combined if you think of it like that. So now we just have to get this one into factored form. So x plus 6 is already in factored form. The bottom has x minus 4. I'm sorry. It would be x plus 4 and x minus 6. No, 8 and 3. 8 and 3. Sorry, I'm thinking. Yeah, doing those factors. Okay, so the factors of 24 are 8 and 3 that have a difference of 5. There we go. So x minus 8 and x plus 3. There we go. So now it's factored. Okay. So it's related to 0. The fractions are combined. It's now in factored form. So now we're ready to list out the zeros. So x plus 6 is 0 at -6. X minus 8 is 0 at +8. X plus 3 is 0 at +3. Hopefully you're just seeing that pattern and you could have pulled out that it was -6, +8, -3 without even doing that math there. Okay, so if you can do that part in your head, do it. Okay, and just list them. On our plus-minus chart, in least to greatest order, we're going to put -6, 3, and 8. -6 came from the top. If you look at our symbol, it's an equal to, so close it in. But 3 and 8 both came from the bottom. Okay, wait 1 second. Should my 3 have been negative? Thank goodness my chart. I didn't have to rewrite. That's -3. Thank you. So both of those came from the bottom. Please open circle those ones. Okay. Now let's put our factors along either side. It doesn't matter, wherever you have room. Our factors are x plus 6, x minus 8, and x plus 3. Let's figure out some test values. Let's go -7, -4, 0, and 9. Why not? Okay. So if I plug -7 down the row, if I plug it into each one, I get negative, negative, and negative. 3 negatives. That region is negative. If I plug in -4 to everything, I get a positive. I get a negative. I get a negative. 2 negatives make a positive. If I plug in 0, I get a positive, a negative, and a positive, which is a negative. If I plug in 9, I get a positive, 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 which is a positive. Now you might notice that we're going negative, positive, negative, positive. That is going to be a pattern that's sustained unless we have a repeat factor. So if you have a repeat factor, that messes that up. But if every factor is unique, you should see that pattern. It might not go minus, plus, minus, plus. It might go plus, minus, plus, minus, but you should see kind of a pattern. This happens because at every zero, we're either going through it or we have an asymptote there. And so it kind of breaks it up perfectly. And it kind of just bounces it up and down. Okay, so let's look at our symbol. Our symbol is a greater than 0. That means we want the positive one. So let's color those in. And then let's interpret that as an interval. We want x's from -6 to 3. I need to include the -6, but not the 3. And then from 8 to infinity, both of those get parentheses. You guys seeing how these are working? Okay. And then let's see if there's any other one that's kind of funky. Oh yeah, so now let's do number 10 because it has the square. It has that repeated factor that I was talking about. So number 10, even though it does have that square there, it's still actually really nice because think about our steps. First step, is it related to 0? Check. Second step, is it one big fraction? Check. Third step is in a factored form? Check. So we're ready to just kind of pull out the zeros. So the top gives us zeros at -7 and 3. The bottom gives us zeros of 5. So let's put those in least to greatest order. And just so happens that is least to greatest order. The factors from the top are open circles because there are no equal to's in the problem. So the -7 and the 3 are open. The 5 came from the bottom, so it's open no matter what. Now, if your factor has a power on it, you must include it in the chart. But what's great is if we have an even power on anything, even powers make everything they touch a positive symbol. So that's an awesome thing. So the only time that would be different is like if you had a negative out in front, that would always be negative, but usually kind of take that negative off and set it somewhere else. But okay, so you can just fill up the chart with all pluses there and you don't have to worry about that, but you can test the number if you want. It will, but you'll see you'll get all positives for that region. So now let's plug in -8, 0, 4, and 6 to answer the question, what's our sign? What's happening? Okay. If you plug in -8 to all of those, you get a negative and a negative and a positive, which is a positive in that region. If you plug a 0 into all of those, you get a positive and a negative and a positive, which is negative. If you plug in 4 to all of those, you get a positive and a positive and a positive, which is a positive. And if you plug in 6 to all of those, you get a positive and a positive, which is a positive. See how around the 0 that came from this, it didn't switch? Think about the fact a parabola has a bounce. You know, it kind of bounces back and stays where it was. And that's why that happens there. Okay. So let's go back to our problem. Let's look at our symbol. Greater than 0, we are looking for the positives. So now let's go color in the positives. Because these are open circles, we do have two distinct regions. There's a vertical asymptote here, so we have to skip that area. So our answer is I can go from -infinity up to -7, don't include it. I can be any number between 3 and 5, and then I can be any number from 5 to infinity. So there are 3 distinct unconnected regions that I colored in. That's why our interval has 3 distinct regions. You can always put these fractions into Desmos. Look for where it's positive if it's greater than 0. Look for where it's negative. It should line up with the numbers that you see there. 11 is bonus. The rest, I think, should be okay. We've done kind of an example of each. So it is your job, hopefully by the end of the period, to get this turned in, or if not by midnight tonight. Okay, so there you go.